Okay. So I like this case here, but we're going to rename this to 2, and we're going to try another case where we're using a little bit simpler numbers. So we're going to copy all this, and we're just going to steal it all, paste it over here, call this specific case number 1. And then we're going to go here, we're going to cut and paste. So specific case, so SC1 is specific case number 1. And then SC2 over here is specific case number 2. And for this first case here, we're going to take this and we're gonna do something like this, but we're going to make it a little bit simpler. So we know we're going from a larger block of memory to a smaller block of memory, right? So so let's say we have something where it's like 16 by 16, right? So there's like this 16 by 16. And our concern is that when we're looking at points 1 and 2 here, that they map correctly to. We want them to map correctly to over here, and over here is just going to be something like this, but a little bit simpler. But not just 3, because 3 isn't going to quite work. So right, we're straddling this center line, right? We're straddling the center line, and the concern is that it's not mapping correctly, right? So now, because this is a smaller range of numbers, this might not fail us. Right, the idea is that when we straddle the center line, that we should map to like here and here, right? And let's simplify some of these numbers here. So the value you want to start with is like 0, 1, 2, 3, right? 3 and 3. So 3, 3, right? And that's our 1 input. And the range that we're using is 0 to 16 minus 1, right? It's a 16 by 16. Oh, it's actually 8. This is a 4, 8. This is an 8. So 8 minus 1 and 8 minus 1. And the output range is going to be... We're not going to translate the output range here. We're just going to... We don't think the problem is translation. Now, we could be wrong. And then this will be, you know, 4 minus 1 and 4 minus 1, right? So 4 minus 1 and 4 minus 1. So we have the input range and the output range. Just make those zeros. The input range and the output range. And we're expecting that it's going to map to this 0, 1, 2, right? So it's actually going to be, this is actually literally going to be 1. So if this is not equal to 1, or this is not equal to 1, so halfway left side, right? And this is going to be SC1, specific case 1. And this is specific case 1 as well. And the same thing, right? We're going to take all these inputs here. Let's condense this a little bit. We're going to take all these inputs. But right here, instead of, you know, 0, 1, 2, 3, we're going to be at 4 and 4, right? So 4 and 4. And that's the number, right? Maybe instead of doing 1 and 2, we can call this A and B, right? A and B and A and B. Right? Let me call this A here, and we call this B here. That might make a little bit more sense when we're labeling it, I think. But yeah, so the same range mapping. So we're gonna take this value, which is on here, and we're gonna map it over to here, right? Okay. So with that, you know, we're going to assume that 0, 1, 2, so we're going to expect everything's going to be 2, 2 here. It's going to be 2, 2. And we're going to see if that works. Now, the thing is that because it's a less granular number of points, that it might just work out because the division will just not do the weird thing it's doing at that boundary. But I think that it's not going to be the case, and we're going to see something weird happen. Now, the other thing is, am I wrong? Am I wrong about how this is supposed to map? Because, well, what I'm saying here is I'm pretty sure that, you know, these 4 should map to here, right? These 4 right here should be mapping to A. These 4 right here should be mapping to B over here. And these 4 should be mapping over to here, right? Like, everything's in discrete units. That would make sense. So, we want everything to snap to discrete units. But is that the sensible way to do things? Is that the way the math should really work? Or do we have some misconception on how the math is supposed to work? Well, if we were doing a, like, nearest neighbor filter, right? Then that sure would be it, right? Because everything kind of goes into, right, these 4 cells here, right, all cluster nicely in here. Everything goes nicely inside of each other, so there's no reason to say that it shouldn't be that. The problem is that, you know, when we're doing the math, we probably get something in the direct center, and then what's probably happening is we're flooring, and we're getting A for both times, right, instead of B. That's my guess. So I'm going to guess that it's going to expect 1, 1 here, and it's going to say that this has failed. That's my guess. So let's give that a run and see if that's the case. And if that's the case, we know that we have to add some, like, rounding logic rather than flooring logic. So right now we're doing right now I'm fairly certain we're doing flooring, but we really need to do rounding. Okay, so we see SC1 halfway right side fail, and if we print off what we have here, so printf dst.x %d\n and dst.x and then y, I'm going to take a wild guess, and I'm going to say that what we're getting is probably 1, 1. We're getting probably a 1, 1, and we're expecting a 2, 2. That's going to be my guess. And also, let me open up my Torch browser and open up chat. So yeah, we're getting a 1, 1, we're expecting 2, 2. So I kind of narrowed down, I distilled the problem down to this, right? So this is the actual, this problem here is the actual use case that I was debugging for, and this is the actual problem, right? So now that we kind of know that, we can go into the code and try to fix it. Now, I don't really feel like doing much work today. So what we're going to do is we're going to try to fix this, adding some rounding code, and then we're going to, like, do some more push-ups to try to, like, get our exercise. And then once we hit our 140 push-ups, yeah, 140 push-ups, we're just going to say, screw it, we're done working, right? That's how we're going to deal with this, because I don't know how else I want to deal with this. I just don't want to do anything today. So this is a GPU fragment shader code, but the code we actually want to look at is in this fragment shader code, right? Fragcom, because that's where we dumped this function. And we have all this crazy math here. And we have this make int32, right? So what we really want is a we want to we want, like, a round int32 here. So this make int32, they need to be a round. So round f32. So round f32 right here and here. And then right here we have a make int32 here as well. So each one of these, we actually want them to be a round function. And the round function is going to take a float 32, and it's going to spit out an int 32, right? Because, like, why would we be rounding? I mean, there's probably some reasons, but for the most part, if we're rounding a float, we probably are trying to get back an integer. We're going to make that assumption in the code. And now that we're here, right, we can go into this macros section, and we can say, hey, we got these, 3-letter macros, and we got 7-letter macros. So let's go over here and just say, hey, we're going to, define. We could actually put it up at the top if we wanted to. Now let's just say define round f32, and if that's the case, we're going to. This can be another utility function, right? So we can do like AAC 2020. And fragcom round f32, right? So round f32 can be this fragment shader code, right? So this will actually be like a utility function that we're going to need to write. Now maybe we don't have to write, maybe I can just write a normal round function, but I really doubt it. I think that the way we're using our types, we have to be a little bit more specific about what we're doing. And so if it's over here, we're going to do AAC 2020, and then instead of fragment shader common, we're going to do poly OGL, just because I think that is the most acceptable place to put it, right? So it's kind of it's not really a polyfill, but I think that's the best place to put it. So round f32, right? Because it's supposed to be a stand-in for another function that also exists in the GLSL code, right? And so this will exist in the GLSL code, but it's not a built-in GLSL command, but it is GLSL code, right? So here's the C99 version of the same thing. So let's not fractionate where our code is too much, so I think that's fine. And then what we can do here is in the fragment shader common code, all right, we have this function. We know that the function we're about to write is going to use it. So int32, and then we know that this code is going to take a float 32, and it's going to be, f32, right? We could just call it f32. And from here, this may just be a wrapper, because all we have to do is return a we want to return make u32, and then we want to round. So let's look for round in GLSL. So round GLSL. So we want to round it and then convert it to a int32. So if we look at GLSL documentation, we have a round and good. So there's a round function. We can just use the normal round function. So let's close this and just say, you know what? We're going to have to use a round function. So let's just call this I'm going to call it round native, and then we're just going to take the float 32 value, and that's how we get it out, right? So round native int32, and that's this function here. Now we also want to define, round native, which is going to be if it's OpenGL code, right? Then we're just going to call it round, right? So round native, right? And this is 10 now. And then we want to do the same thing here, right? So we're going to duplicate this. 8, 9, and 10. And you can steal this. And this is going to be called round native, right? So round native is number 9. Instead of calling it round float 32, we're going to call it round native. Right? Just kind of like a weird thing to call it, but oh well, that's kind of what we're calling it, right? So you just want to keep these names exactly the same as what's going on here, right? Okay. So now that we have round native and round float 32, right? But you can start to stub in more of this stuff. So we already have this, right? We already have this. We already have this, but we have to do these poly OGL things. So let's go over to OpenGL polyfills really quick. So File, and then so poly OGL functions. And within here, these are kind of the C99 versions of GLSL code, right? So it says, do not paste in GLSL code. It looks like this is a master kind of section of all this stuff. So we're going to keep with the naming convention here, right? So GLSL, polyfill, round native. So we have a round native, and then we have a round float 32, and round float 32 takes a float 32 and returns an integer. So the names are slightly confusing, right? Because they both take a float 32 and round it, but it's just the return type of one of them, right? So round native, let's do round native first. So, you know, it's going to take a float, it takes a float 32 input, but it also outputs one. So float 32, right? And then we need some type of rounding function here, right? Don't know what that is yet. And then over here, we want to just take this and same thing, but it takes a float 32, returns an int 32, and it's not called round native, it's called round float 32, right? Okay. So to get the float 32, what we're going to do is we're just going to say, you know, int 32 out, int 32 equals, and we can do, we can take round native, right? We can take round native, give it the float 32 value, and then after we've rounded it, we can just cast it to int 32, right? Easy as that. You can just use the other function itself, and then we can return int 32. Okay. Over here, I don't know how we're going to do a round, right? So I don't know how you do a round in C99 code. So let's give a look at that and see how to round in C99 code. Then we can also put that in our shortcuts. So how to round in C99 code, and it gave us some very helpful suggestions. Not really. So there we go. So we can just include math.h, and there is a round int float. Rounding halfway cases away from 0 regardless of the current rounding direction. Not a C solution. Int x plus 0.5 is invalid. algorithm fails for x just less than 0.5. Really? Yeah, because 0.5 plus 0.5 gives us a 1, right? That doesn't round down. Yeah. This is interesting. This looks kind of crazy. Arduino C. Oh, no? I don't see what's wrong with this code, but it doesn't compile, huh? So let's just, it looks to me like what we really want is we can look at how GLSL rounds. Let's go look at GLSL round. Right, how is that computed? Because it might tell us how round is computed in GLSL. Rounds to a value equal to the nearest integer to x. The fraction 0.5 will round in the direction chosen by the implementation, presumably the direction that is fastest. This includes the possibility that round x returns the same value as round even for all cases of x. Interesting. So if we want something predictable, that's not going to be it. How about round even? What's round even? Interesting. Round even. Okay. So it looks like there's like a round F or something. Round F. Rounds halfway cases to 0. R int. Let's go look up some more stuff. Round function C99. Okay. God. And math.h, so we can just do a round. So what's the difference between round and round f? Okay, let's just do math.h and do round.f. It's in C99, so cool. So let's go into here. Let's go into our library. libchan. And we have like a whole bunch of dependencies in here, I believe, right? Time.whatever. There's no math.h. Include directives standard libraries, right? So let's just, you know, tack on include, you know, math.h for round f. All right, so we just want to get the round function going here. And then in here, all we're going to do is we're just going to use this as a wrapper, right? So round native. And we're just going to return a round f32. Round found in math.h. Okay, make a note that round is found in math.h, so we want to make a note of that. And so here's our round native. Here's our round float32. And then here is our fragment shader code. Now we've declared things, but we need to still undeclare them. So we want round native and round f32. They need to be undeclared. So over here, we're going to duplicate this twice. And we have round native and then round f32. And that is going to be 8. And then we have 9 and 10. Okay. So the next thing is, okay, yeah, we have these. And that's all cool and stuff, but now we have to actually, you know, use it somewhere, right? Oh, hey, we're already using it. Cool. So let's give it a run and see if we can get this compiling and see if it changes what test fails, right? So we may have some other tests that previously passed that will now fail because at some point we were just like trusting what the output was and changing the output to... We were just like, oh, it expects this value? Okay, just change the test expected values. We kind of were being lazy with some of our tests. So let's just look at this and see what happens, right? So we're hoping that, okay, so fragcom, halfway right side, fail. So that sounds like we got a little bit better, right? It looks like we got a little bit further than what I was expecting. So let's go over here to, this would be frag comment, right? So halfway right side right here, SC1, and this is SC2, right? This is SC2. So SC2 specific case number 2. And so we're just going to tag this with SC2. We're going to tag this with SC2 as well. And it was the halfway right side that's failing us. So what we're going to do here is this shouldn't be a 16 plus 1. This should be a 16 plus 0 if we were correct, right? Because it's because we're talking about, so 0 to 15, right? So that's why we have a 16 minus 1, because 15, okay? And then once we cross this 15 border, we're at 16, right? So 16 plus 0. Right, so this should be a 16 plus 0. So this thing isn't even correct, but I don't even think this test case is correct, right? Because, right, 16 minus 1, 16 plus 1, we're skipping over 1, right? So let's just do a printf of dst.x %d \n, and then, you know, dst.x, and then do the same thing for y. So dst.x, dst.y. We're going to run it again, and I'm assuming that it's going to give me the same message. It's going to print these off, showing me what the outputs it got were, and then we're just going to change this +1 to a +0, and then I think it'll actually work. I think then we'll have some of the test pass. Yeah, SC2 halfway right side fail, and all we're going to do is say that we think the problem is that this should be a +0, right? And then another thing that we're going to do is we're going to collapse this, and we're actually going to test it twice. Or actually, let's not do that. Let's just say, let's collapse it here, right? So let's just do the same comparisons, but it's the same exact comparisons, but it's just, we collapse the calculations, right? So we're just going to take this and collapse it and see what that is. So 432. And this is just a way to, when we know this test passes, we'll know that, 432 is equal to this, right? And then this as well. Let's look for what that is. So yeah, I am getting kind of tired of these tests, and we have changed the behavior though, right? We have, since yesterday, we have changed the behavior of how that round function works. So I don't think that it's going to like save us in terms of like what's going wrong with our shader code, but I think it's going to give us one step closer to more correct output based on the output that we desire. So now we're at test index 34, and we can see that DX 449, and we're getting 450 and 400. So I'm going to guess that test number 34 is probably something where I just kind of went with the flow, and I'm like, you know what, whatever. I'm just gonna, whatever the test says the answer is, I'm gonna make that the answer. And I think that's what happened here. So I'm fairly certain that, yeah, because I think it was like on the border, right? It was like between 449 and 450. You can see how it's kind of off by 1. So what we're gonna do is we're just gonna go into the test code here. And we're going to say, you know what, we like the current algorithm. It seems to be working properly. Let's not try to, what do you call it? Let's go to 34. Let's go to test number 34 here for a second. So yeah, we got this kind of situation going on here. And if we look at 449, right, 449.5. So we said, oh, hey, this could be 449, or it could be 450, right, according to our calculations, right? And now it's saying that it expects 450, and we're going to say, you know what? Okay, I believe you. I think that's correct. So we're just literally going to go into test number 34. And the thing is, well, like, okay, well, if you're just going to go into the test and hard code the answers based on the output you got, like, is there any use to that? And there is use to that, because tests are not just to verify that code is correct. It's also to help protect your code against accidental changes. So we look at that value, we see it's off by 1, and we're like, you know what, that's good enough for me. We have the behavior that we want. We changed around the behavior of the code. I'm good with that. So we want 449 and 400 for, this is test number 34. So 34 is right here. And the output is 450 and 400, right? So instead of 449 here, we want 450. Also, that probably means that, anywhere we're seeing 449. Well, not necessarily anywhere we're seeing 449. Because now 450 is mapping to 450, where 449 is mapping to 449, right? Okay, so we're going to just change it one little step at a time. To make sure that we don't just shoot ourselves in the foot and add more work than we actually have to do. And then once we get this working, we're going to just do some more push-ups, and we're going to just keep on kind of powering through this until we can, so 38. So now we got to go down to 38. So over here, okay, so now we have 38. 38 is this test case here. Once again, what do we have? We got 449 is what we expected, but we got 450, right? So where we see 449 here, we're going to change it to 450. And I'm satisfied that that's correct because according to my notes, right, we're off by 1 and we changed some things around. Yeah, I'm satisfied with that. Okay, so now we're going to clear this and we're going to keep on going through these tests. Okay, so now we're on 39. Probably the same deal, right? So 449s. We got a 449 and a 449, which maps to 449 and 450. Or the outputs that we got were 449 and 449, but we want 449 and 450. So 39, 449, and 450. Makes sense? That also probably means that... Let's just take our time here. Let's, because if we don't take our time, we could just end up taking 1 step forward, 1 step back. So let's just kind of go slow through here. Let's not worry about trying to speed through here. We've already spent enough time on this. Okay, so we're at 42 now. So 42 is over here. Okay, so we're getting further. And I guess it's the 449, 450 thing again. Yeah, so we have... We were expecting 449, but we got 450. And I'm just going to say, you know what? We're actually expecting 450. So, these are, once we hit the 45th test, we'll be done, right? So we have 3 more tests, so minimum, or maximum 3 more compiles, and then we're good, right? So, then we can see if anything else crashes, and then we can kind of continue trying to figure out what the heck is wrong with our rendering code, right? So 43. So test number 43 is here. We got the 449, 499, 449. This is the same, this is different. So the Y, we just need to change the Y to 450. And that is for test number 43. So yeah, 450. And it looks like there's maximum 1 more test that needs to be changed if this test fails, right? Because we see this 449 here, which might need to be changed to 450. Because 450 maps to 450, it seems. Yeah, so this is going to map to 450. Okay. So now I'm fairly confident that all our tests will pass. And then we can kind of figure out, oh crap, I just realized that I'm not even showing the code. So luckily we're just kind of writing some test code here. How long have I been going here for? How long have I been recording? So I've been recording for almost 38 minutes without showing what the heck is going on. That sucks. Okay, so we're over here. That looks good. We go over here. We press the U key. We go over here. And we see that things are not quite lined up the way we want. It's a little bit better, though. It's a little bit better. But it's not quite what we expect, right? So let's go down here for a second, right? So it's a little bit more centered, though. It's a little bit more centered. But it almost seems like... so that algorithm is... It's the rounding algorithm that we're using now is maybe slightly more correct. Where it makes sense, where we did expect all the way to the left to round to this red pixel. We expected all the way to the right to round to this pixel, right? But what we're not expecting here is the fact that we're only getting like a quarter of the first pixel. We're only getting a quarter of the first pixel, but we're getting closer. We're getting closer. And it does seem that the problem is with our rounding logic. Our rounding logic is a little bit wrong still. And so we need to still kind of refine it. We need to refine it a bit until it snaps perfectly. Because I'm pretty sure that the ranges that we're iterating over are correct, but the rounding logic is slightly off. It's just ever so slightly off. Because now that we've fixed the rounding logic a bit, we're getting closer. But it's just not quite what we want. So, now, my question now is it because this round, is it because this round is taking whatever is right at this border? Are we at this border? Are there a whole bunch of pixels that could have been either swayed right or left, and then it just chose to take the right side, right? And then over here, this part maybe should be black. No. Well, maybe. Well, actually, yeah, because, well, so this green part should probably be red, right? And then this green part over here is green, and this little black strip should probably still be green. So I think what's happening is the rounding algorithm is doing some like arbitrary choices when we're on like 0.5, and that's creating some problems with the mapping. That's my guess. So we got to think about how we're rounding, because we're trying to like do this pixel perfect mapping of one region onto another with like discrete coordinates, and we're obviously kind of failing a little bit, right? We don't quite understand. This tells me that I don't quite understand the problem. Like, I very almost understand the problem to where this is almost kind of zoomed in perfectly, but it's not quite correct, is it? So we want to keep on hacking this out and try to figure it out, but I don't know what's going on. So I'm going to we got to figure out another test case that can emulate this problem. So we have kind of these, we have this region, and we want to make sure that these 4 pixels on the edge are kind of like going to fit inside of what we're doing here, right? So we want to mimic a test case that will kind of look at this. So we did some test cases that I thought kind of simulated the problem, but I guess not quite. Or we didn't do a test case that simulated the problem. We did something like corner, 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 and then we did like midpoint, 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 midpoint. We didn't do like corner left, corner right, corner right. We didn't do these like 4 quadrants in the corner, right? So there's 4 pixels in the corner, and they're not quite mapping correctly. So we want to build a test case that will kind of look like this. So the first thing we're going to do, we're just going to snip this. We're going to put it in our imgur so that we can keep track of this test case that is, it's closer. Like, this looks like it might be further off, but I do think this is closer. I think that the rounding logic, I don't think we can rely on the rounding logic that we're using. So let's save this as, I'm going to save this as rounding is a bit better. But yes, by rounding instead of flooring, we got closer. But I think the problem now is that when we're at like 0.5, in terms of rounding, there's some arbitrary choices that are being made, and so it's not mapping exactly correctly. So we'll have to continue on, try to figure out this math, but we want to make sure that this math is not off by even 1 pixel, right? So we want this math to be pixel perfect, and that's kind of like what's screwing us up, right? The whole thing that's really screwing us up here is the fact that we really want this as pixel perfect. Rounding is a bit better. So we're going to open this up for a second. So we're going to open up paint.net. We're going to crop it and kind of visually inspect it. But it looks like everything is kind of nicely lined up, right? It's not a... Before, when we were doing like a ceiling, right, everything was kind of shifted over to the right. Right now everything's nicely centered. But we're still we're still experiencing something where we're off, right? So we're getting closer to what I'm expecting, but not quite. And the thing is, this sucks, but at least once I write this kind of mapping logic that's pixel perfect mapping, I can, reuse this function for other things in the future, right? And this function has like all this crazy test code written for it, so we'll know that it's absolutely correct. So we're getting closer. We're getting closer. So We can make a note there. Put that in like Andale Mono. Or Monaco. Monaco? Monaco. Monaco? Monaco. Change the font to like, I don't know, white. Okay. And then we'll up that font size. Okay, yeah. So we're just gonna make an inspirational message for ourselves. We'll call this Getting Closer. .png. Close this. Don't save. I'm gonna go to Imgur, upload that. And then I need to do more push-ups. So we're gonna do the push-ups off stream, I think. I wanna actually get an idea of how much actual work I'm doing. And so when I'm not feeling like working, I don't wanna just kinda, you know, I don't wanna just, okay, that actually looks kinda cool. I don't wanna just take a whole bunch of breaks and then have that on my stream, right? Because then I'll think that I've done more work than I really have, right? I want an accurate idea of how much work I'm doing. So Getting Closer, we're gonna call this Getting Closer.png, put that up there. And then we can put a link in here, right? So we can put a link and say, rectangle chord remapping tests. Alright, so that's kind of what's in this section. Really though, if I'm going to do that, I do want like a nice section divider. And this is kind of a ridiculously long name, but a lot of my function names get this long. If we use some macros to shorten these names, it just makes it really hard to hunt them down in the source code later. So we're not going to do that because then it just makes it harder to find things. So, so we have a specific case number 1, specific case number 2, and we're about to do a specific case number 3. SC3. And let's just actually steal this, right? So let's steal this Imgur link. Because this Imgur link is the, you can just do i.imgur, will that work? I don't know. Let's try it, let's see. If we do like i.imgur in my Torch browser, does it like accurately know what the hell I'm talking about? Or does it like go, hey, no domain, something, something. Yeah, so we can't just throw that in there. That's fine. So let's not put that there then, right? Let's just put it over here, right? And let's color it a little bit different because the colons... This looks like my end of comment sequence here, the colon / / so I can't really write it that way. And let's make sure that works. Okay, getting closer, cool. So in my little browser, I can see, hey, there's the thing. That's cool. That's what I want to base my tests on. And we really want to use round F here. Okay, so yeah, I'm going to stop the stream now. I'm just going to keep on doing little streams until I can get more and more work done slowly and slowly. But this title screen, this is not 69 anymore, is it? This was actually 70, so this was 70. And let's change the number here. Before we end the stream, let's make sure that we have the correct number. So 137, it is 138, GPU view, done. And now we can stop the stream, right? So, yeah. So we're just going to keep on hacking away very slowly and getting a little bit more exercise and a little bit more exercise. Once we got our exercise done, we'll be done for the day.